Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to learn equations of motion by using the calculus method, and after that we will see by using velocity time graph also. Okay, but before starting the equation of motion, we should understand very well what is the uniformly accelerated motion and what is the non-uniformly accelerated motion, and in which situation we have to apply equation of motion, and in which situation equations of motion will become invalid. Okay, so all these things we are going to learn in this video, students. So let's start the video. So here you can see uniformly accelerated motion. So see here, in uniformly accelerated motion, acceleration of the object is constant. Again I am telling, acceleration of the object is a constant, and three equations of motion is applicable. Okay, so remember that here, whenever the acceleration of the moving object is constant, that time only equations of motion is valid. Okay, so if I talk about here, let's take for example acceleration of the object. Let's take given for example 2 meters per second square now, and this is one constant value. That means in this situation we can apply equations of motion. Okay, similarly if I talk about here another example, like when any object is thrown in a gravity near to the surface of the earth, or we can tell planet. So in this situation for the earth, what will happen at here? The value of A will be how much here? Approximately 9.8 meters per second square, and here also you can see very well this is one kind of constant value. So in this situation also we can apply equations of motion that we will learn under the motion under gravity. Okay, but remember that here this is valid near to earth, near to earth. Later in the chapter of gravitation you will see this gravity value also it keep on changes, okay, and remains maximum at the surface of the earth. Remember that. Okay, so what we have understood, acceleration should be constant. There only we can apply equations of motion. And which kind of motion? Uniformly accelerated motion. That means equal change of velocity in equal interval of time. Is it, students? We have learned before also all this. So now second one, what is this here? The non-uniformly accelerated motion. So see here, in non-uniformly accelerated motion, acceleration of the object is a variable. Okay, and three equations of motion is not applicable. Okay, so what is this? If the acceleration is a variable, equations of motion is not applicable, then what will be there? In that situation we have to solve the question by using the differentiation and integration formulas of acceleration and the velocity. That and all we will see it, not a problem. So if we talk about here example, let's take for example, maybe acceleration is given as a function of time, maybe acceleration is given as a function of position, maybe acceleration is given as a function of velocity. Any possibility may be there, but remember that here this acceleration is what? This acceleration is the variable. So I hope so, very clear. Uniformly accelerated motion, acceleration constant. Okay, non-uniformly accelerated motion, acceleration is not constant, it is variable. And here what will be there? There will be the unequal change of velocity in equal interval of time, or we can tell equal change of velocity in a unequal interval of time. Okay, all these things we have covered in a previous video also. So I hope so these basics are very clear to you. If you are very clear with these things, then only we can understand further things here. Okay, so now here you can see what is this equations of motion by calculus method we are going to solve. So see here, let initial velocity of an object is u at t equal to 0, x equal to 0, and final velocity of the object is v at t equal to t, x equal to s. Okay, that I will represent here. Let's take here, this is the origin here, no? X equal to 0, is it? And the object is going to travel s, and remember that this s is the displacement. What is s? Displacement, the shortest distance between initial and final point. Just for the simplicity we are taking it in a straight line without changing direction. Okay, and here what is the value of x? The value of x will be s. That means object is moving from where to where? X equal to 0 to x equal to s. Now if you talk about here the velocity, initial velocity u, final velocity v. Okay, so remember that here whenever we'll write the velocity, so here please, velocity always will use the term here v. Here also How much here? V. This V will represent the velocity. Okay. So what is here the initial velocity? Initial velocity is u. Okay. And what is the final velocity? The final velocity is v. Again, I'm telling that here v equal to means velocity. V equal means velocity. U is the initial velocity. V is the final velocity. Okay. Similarly, if we talk about the time, so for time, what will be there? Remember that here I will use t equal to, and here also I will use t equal to. Now this t equal to will represent the time. Okay. So now what is the initial time? We are starting with t equal to 0. So here I will write here t equal to 0. Okay. And after that, what is the time? T equal to t. So I will write here t equal to t. Is it? So this is the situation. The object is moving in this direction here. Now just for the simplicity we have drawn here. So now what we are going to do here? We are going to drive here the first equation. Very, very important for the exam. No? So first equation. No? So what will be here? Remember that here it is when applicable, when a is constant. Very, very important. When applicable, when a is constant, na, and the body is accelerating in this direction with a uniform acceleration here. Na, a is constant. So remember that to prove the first equation, we will start with the a equal to dv by dt. No, we will start with the, remember that here to prove the first equation, we will start with the a equal to dv by dt. Okay, even you can put in a box also. Okay. Now after that, we will just do the cross multiplication and all. We will rearrange it. So it will become here, see, dv equal to a into dt, integration sign. And see here, what is a? A is a constant. Okay. So what we can write here, see, this dv equal to a is constant means it will come outside here, and here integration of dt. Okay. So here which limits I have to put? Here we have to put the limit of velocity. Here which limit we have to put? We have to put the limit of time. Okay. So at t equal to 0, what is the velocity? The velocity is a u. Okay. And after time t, that means here t, what is the velocity? The velocity is the v. Okay. So this thing is ready now here. Is it? And why this a came outside? Very, very important, because a is constant. If a is variable, that further we'll see in a non-uniformly accelerated motion, there this a will not come outside. Remember that. Okay. Now after that, what will happen that here? Now we'll go ahead. Integration of the dv means v. Okay. Lower limit u, upper limit v. Okay. And here a, integration of dt means what? T here. Okay. And lower limit 0, upper limit t. Okay. Now what will happen that here? We'll put here the upper limit, that means v equal to v, minus lower limit v equal to u. So v minus u is equal to a. Here what will happen that here? Upper limit t equal to t minus lower limit t equal to 0. Okay. So when you will simplify this, what this will come here? It will come here v equal to u plus at. Now remember that this is the first equation of motion. V equal to u plus at when a is constant. Okay. And if in case, further also we'll see, if you wish to write here in a vector form, now in vector form, what this will become here? Vector v equal to vector u plus vector a into t. Okay. And this one is here in a vector form. Okay. This is here in a vector form. Remember that here, this equation is valid only in a one dimension, but this equation is valid 1D, 2D, 3D. In all the situations, this equation we can use here. Okay. So students, here we have just to do the derivation for the first equation. By which method? By the calculus method. Okay. Great. Now the second equation. So for the second equation, remember that here, for the second equation, it will always start with this one here. See, we will start here, v equal to dx by dt. Now this is the basic, v equal to dx by dt. Second equation will start from here. And again I am telling you, a is what? Constant uniformly accelerated motion. Okay. Now after that, what will happen that here? Further we'll go ahead. So we can write here, see, this dx equal to v into dt. Okay. And we'll put here the integration. Is it? Now remember that here, after that, the next step is what? In next step, students, this v value we have to put. What is the v? V equal to u plus at, that we have done before. Okay. So remember that here, this will become here what? This will become here u plus at into dt. Okay. This v value I have put here. Okay. Now after that, what will happen that here? We will just simplify this here. So here this integration of dx is equal to, just simplify this, so just multiply inside, it will become here u into dt plus at into dt. Okay, next one, see here, integration of dx is equal to, here u dt, u constant outside dt plus anyhow a constant t into dt. Okay, now up to this we are ready. Now we have to put the limits here. Okay, here also you can put the limits after solving all these things. Limits we will put here. Here dt, so here we will put the limits of time t equal to, here dx is this, so here we will put the limits of position x. Okay, so now after that what will be there, initial time t equal to 0, and initial position is how much here, 0, that we have seen in a diagram, previous diagram. You can see here now when t equal to 0, x is 0, when t equal to t, x how much here, s. Okay, so after that when the time is t, and the position how much here, s, is it? Now after that students, we will just simplify this. So integration of the dx how much here, x, lower limit 0, upper limit s, is it? Now after that here u, integration of dt means t, lower limit 0, upper limit t, now a. Integration of t dt, formula t to the power n plus 1 by n plus 1. Okay, so it will become here t square by 2, and here where to where, 0 to t. Okay, after that again we will further simplify this. So kindly put here the upper limit, x equal to s minus x equal to 0, upper limit minus lower limit. Okay, similarly u here, and here t minus 0 plus a by 2 here, again upper limit t square minus 0 square. Now just for your basic understanding we are doing this. So it will become here s equal to ut plus half at square. What is this here, students? Formula s equal to ut plus half at square. Now this is the second equation of motion, and in that remember that here this s is the displacement. Okay, what is this s, students? This s is the displacement. Okay, and even further also one more equation is there, that also please remember that here, one more further equation, sometimes very useful, s equal to u plus v by 2 into t here. Now this equation also, we'll see when we'll do by the VT graph, na, this equation will come. Okay, but remember that here so many times this equation is also very handy instead of this. Okay, after that if I write here in a vector form, because you know very well this equation valid for 1D only, but this equation we can use even in a 2D, 3D also. Okay, so in vector form remember that here this s is called a displacement vector. Okay, so that we used to write here delta r, displacement vector is equal to ut plus half vector a into t square. This is the vector form. Okay, if you will remember that, that will be the vector. Further later also we will see that, that's not a problem, but okay, we are getting the opportunity to learn, so we can write here. Okay, so this is what, students, this is the second equation of motion, we have done it. Next one, students, this is the third equation of motion. So for the third equation of motion, remember that here, third equation of motion, which formula will write here, remember that here, a equal to v into dv by dx. By default we are seeing the object is moving along which direction, x direction. Okay, so now after that again we will do here the cross multiplication. So it will become here v into dv is a into dx. Here limit means integration sign. Now here what we have to do here, dx means x equal to, now position, dv means v equal to, remember that here depending upon what is given, whether dx means x, dv means v, then only we'll put the limits. Okay, so remember that when x equal to 0, initial velocity is u, and after that when this is s, final velocity is v, is it? So now after that integration of v dv is how much here, in the same way like integration of t to the power n dt, this one here, see, we will write in this way, v to the power n dv means it will become here v to the power n plus 1 by n plus 1. Okay, basic is always same, and you can add here if it is the indefinite integration plus one constant also, na, indefinite integration, but here we are doing all definite integration. Okay, so v into dv means it will become here v square by 2 u to v is equal to, anyhow a is constant, and here we can write here integration of the dx. Okay, let me write here, no problem, x equal to 0 to s. Okay, so what this will become here, 1 by 2 upper limit, that means v square, lower limit minus u square, a is a constant, integration of dx means x, and here also 0 to s. Okay, so what this will become here, see, half v square minus u square is equal to, see here, a, and upper limit anyhow x equal to s, lower limit x equal to 0. Okay, after that what this will become here, when you will simplify this, it will become here, remember that here, v square minus u square equal to 2as, or you can write here v square equal to u square plus 2as. Okay, see here. Now, so this is the equation. Remember that here, especially the first equation and second equation we used to write here in a vector form, but the third equation is always used to be in a scalar form. Third equation, in which form? It is scalar form here, scalar. Two equations vector, but third one is scalar, because here the dot product of the vectors, how much is scalar? So if I write here, if you want to write here, no? So if I write here, for let's take for example here, if in case, okay, we want to write here in a vector form, because dot product of the vectors are scalar now, so only I am writing a C. Vector v dot vector v is equal to vector u dot vector u plus 2 vector a dot displacement vector means I used to write here the delta r, even you can write delta vector s also, not a problem here. Okay, again I'm telling that here, if you are thinking like this, you can write here the vector s also, not a problem. Okay, so I hope so this equation, third equation, is also very, very clear to you here. Okay students, so now we have done the equations of motion by using the calculus. Remember that here we have done for the uniformly accelerated motion, but same basic we have to use for non-uniformly accelerated motion also. Okay, and if I talk about here one summary, so in a summary I will just tell you one thing for calculus method. When we are going to prove the first equation, the equation is looking like a first equation. Even when we are solving the question, we will always start with the a equal to dv by dt. Okay, if options are looking like a second equation like that, so we will start with the v equal to dx by dt. Okay, and if the options in a question is looking like a third equation, so we will start with the a equal to v into dv by dx. Okay, so all this starting we should know. Depending upon the question, options are looking like a which kind of equation, based upon that we will start that. Okay students, so now we have done here the calculus. After that we are going to do for the, you can see very well, equations of motion by VT graph. VT graph means velocity time graph. Okay, so let's go through it. From this also question used to come, no? Even derivation also in 11. So here, let initial velocity of uniformly accelerated object is u at t equal to 0. Okay, and final velocity of the object is v at t equal to t as shown in velocity time graph. So remember that here one thing here. First thing I will tell you, very basic thing. The basic thing is what? Basic. Remember that here. Basic is what? You know, acceleration is constant. No? Equations of motion, what is constant? Acceleration is constant. And you know very well, acceleration means what? The slope of VT graph. Okay, so what will happen that here? See, the slope of VT graph, that means we can tell what? The tan theta. This tan theta should be also constant. That means this theta should not change. Theta is constant. Theta is constant. In which situation theta is constant? Theta is constant when this is the straight line. Straight line only, what will be there? The theta will be constant here. Okay. So in a velocity time graph, what will happen that here? It will go like this here. See here, like this here. It will go like this. Okay. And after that, if I write here, this is the, this side time, this side here is the velocity here. Okay. And after that, if I write here, let's take here, I have taken here in this direction. No? And I will write here in this direction also, okay, because we need it somewhat. Now, so remember that here, this is the time t, this is the initial velocity u, and this is the final velocity v. So at t equal to 0, initial velocity u, at t equal to t, final velocity how much here? V. Okay, and what I have told you here, students, acceleration means the slope of VT graph. That means here, remember that here, to prove the first equation of motion, we will use here the slope. Which concept will use here? The slope of VT graph. What will use here? The slope of VT graph. Okay. So if I write here the coordinates. Here coordinates how much here? 0, comma u. Here coordinates how much? Remember that here t, comma v. Okay. So for the straight line motion, what is the slope? Slope is given by like m equal to y2 minus y1 by x2 minus x1. What is the slope formula? You have learnt in a maths, y2 minus y1 by x2 minus x1 here. Is it? So this thing we are going to use here. So remember that here this acceleration is given here. I can write here in a very basic way. See, v2 minus v1 by t2 minus t1. Okay. And let's take, for example, for basic understanding of writing here, let's take this is t1 comma v1. Okay. And this is the t2 comma v2. Okay. So just put the value. v2 minus v1 means v minus u. t2 minus t1 means t minus 0. Okay. And when you will simplify this, it will come here a equal to v minus u by t, or we can write here what? V equal to u plus at. So whenever we are proving the first equation of motion by the velocity time graph, what we have to see? We have to see here the slope. Remember that here now the slope of velocity time graph will be used to prove the first equation of motion. Okay, great. Now students, after that, second equation of motion. So for the second equation of motion also, just let me draw here. One straight line here. See here, please, like this. We have the options to draw a straight line very straight, so we can draw here. Is it? So see here, this is t, this is v. Okay, and after that, let me write here. See, this is no, and this is like this. Not going. So see here, this like this. Not like this. It went here. So remember that here what will happen that here, if I'll write here, again we know very well, this is what? The time t equal to 0, and here time is t equal to t. Is it? Initial velocity is u and final velocity is v. So remember that here, second equation, so basic. You know very well, integration of dx means v dt. Integration of dx means what? V dt. What is the significance of integration? Significance of integration is the area. Okay, so remember that here, area under VT graph. Area under VT graph will give us the displacement that I have told you. Okay, so what we have to do here? We have to calculate this area. Now, we have to calculate this area. And you know very well here, if in case, remember that here, if we talk about here, what is the trapezium? I think so, trapezium is this. Okay, trapezium. Is it? So, trapezium. So, here what will happen that here, let's take for example, given like this is one side and like this here. Okay, and this is A, this is B. Now, the length of two parallel sides is A and B, and distance between two parallel sides is H. Okay, so what is the area? Area of the trapezium is given here. Remember that here, half sum of parallel sides into distance between the parallel sides here. Okay, because you can see here in a velocity time graph, this is looking like a trapezium. Okay, like this here. See, remember that here, this formula. Now, two parallel sides. This one is A, no? Length of one parallel side, length of second parallel side B, and the distance between two parallel sides is how much here? H. Okay, so this thing we will use here. So remember that here in this situation, what is this length? No, parallel side length. This length how much here? If I write here, this length is a V. Okay, this length how much here? This length is U. Okay, and the distance between these two parallel sides, this one how much here? T equal to 0, T equal to 2 means this is T. Is it? So students, here if I write here the displacement is equal to what we know, area under VT graph. Okay, so area means what here? Half U plus V into T. Now even this formula I have told before also when I was doing the derivation by the calculus method. Is it? Now after that what will happen that you see this S equal to half U plus, we'll put the value of the V. This is V is this now. What is the value of V? U plus AT. Now into T. So when you will simplify this, it will come here S equal to UT plus half AT square. Okay, S equal to UT plus half AT square. Remember that here for the second equation of motion, we have to see area under the velocity time graph. What we have to see? We have to see the area under the velocity time graph here. Okay, great. Now the third equation means nothing like any specific calculation and all that. We have to just eliminate the time. Okay, so here please, we know V equal to U plus AT. Now So from here, time how much here? V minus u by a. I will make here equation 1. Okay. And what is the second equation? You know, s equal to ut plus half at square. Okay. So what will happen that here? See, s equal to u. What is the value of the t? V minus u by a plus half a. T how much here? V minus u by a whole square. How we have done? We have done from equation 1. Okay. So just very easy. When you will simplify this, it will come here v square equal to u square plus 2as. Okay. Can you see very well? Can you see very well? So students, in this video we have learned equations of motion, when to use for uniform acceleration, that means when a is constant, when not to use when non-uniform acceleration, that means when a is a variable. And here we have done the derivation by the calculus method and by the velocity time graph method also. So okay students, I hope so this video you have understood very well. Keep studying, keep growing.